Hello, everyone. Welcome to part 3 of Fluffy. We got a lot of progress, but I ran into basically a contradiction. So I'm going to have to go through this with a sort of fine-tooth comb. We have the logic down. It's just a matter of basically making sure the execution works. Anyways, let's go. Again, to have a difference of 9, there's only two at most, three triple-headed beasts in each box. So that means that you cannot have a difference of 9 between normal digits. So these must be the digits that are different. So we're marking it blue and red, and everything in the box is going to be different. So any difference of 2 has to have at least one triple-headed beast in it. So this must have one. It's red, which means the rest of the row cannot have triple-headed beast. This must be blue, which means the rest of the column cannot have triple-headed beasts. And we have similar things here. And I remember, yeah, so similar things here. So that means these cannot be triple-headed beasts. These cannot be triple-headed beasts. This was 1. You cannot have triple-headed beasts in the same box be in the same row or column. And we know one of these two is, so both of them must be. So this is red, this is blue, which makes this red, which makes that blue. So this must be blue here. This is red because it's opposite there, so this is blue. So we had this situation, right? So this could not be, one of these is red. These couldn't be here, couldn't be here, couldn't be here, and we have that. So we ran the scenarios. We could not have one here because if we had we have to have it, we tried to have in box 5, it was being 1, 2, and 3, but the problem is that it would have to be all 3 of these being essentially 3-headed beasts. You cannot have both of these be here. Why was that? Because that would eliminate here and here. So therefore, oh yeah, the problem was that this would have to be blue, so both of these must be red, but then, or one of these, that's red, they're both blue, but the problem is we know the red one's here and the blue one's here, so it cannot be the same set. And that's the reason why we know this can't be these 3 can't be the ones that are triple-headed beast, it must be these 2. Therefore, none of these are triple-headed beasts. We found out it could not be that one. If it's this one, that if it's red here, that would force this to be blue. That's red, and you have a red, blue would force that not to be blue, so that would have to be blue. But then you'd have blue and red in the same row in this box. So it couldn't be here. It couldn't be here either for the same reasoning. Right? If this was blue here, that means this is red and blue. Red eliminates red here, so that would be red, so that can't be red. So then you'd have red, blue, blue, red, but then this would have to be blue. And that would be in the same box, so that's not allowed. I think it's same here. Was that the right one? We know it's that one. If this is red, that makes this blue. No, I think it was here. If this is red, that would make that blue, so that's red there. So red, blue means this can't be blue, so that's blue, so that can't be blue. So this would be blue and red, but that would have to be red and blue, which is not possible. So this can't be either. And so I think it was this versus this. Was that right? And we labeled these, actually, huh. Was it here? So if this is blue, that means this is red. So that can't be red. Maybe it's this one. If this is blue, that means this is red, so that can't be red, so this is red. Nope, that's right. So if this is blue, this would be red, that would be blue. So blue would have to be here, but this red here eliminates red here, so blue and red would be in the same column, which is not allowed. So this can't be blue. And then we did something to eliminate this possibility. What it was, okay, I remember now. It was that we started labeling all the possibilities, right? So we had A, eventually this became B, that was C. Let's see, it was this one, which means this one was D. This is D, so this is F, and that was E. G, H, and I, right? But we labeled them all the possibilities. So again, then Z, this was Y, this was X, W, V, U, T, S, and R. So then we said, what are the possibilities to add up, right? So this A is Z plus Y plus T. So ZYT. Z was C plus A plus D. Y was B plus A plus H here. And if it was here, this was E plus A, because this could have been E or V, and this could have been E or V. So A, E, and B. Here, C was Z, U, and X. B here was, so B here was what? A, no, it was X, Y, and S, because it would be the same as that one. B here is X, Y, and V. X here would be B, C, and I, no matter what. So these were always the same. All of these were always the same, because we were saying this was U no matter what, whichever one. This was W no matter what. This was D no matter what. D here. Okay, so F here was V, U, and R. F here was W, U, and R. U here was E, C, and F. U here is D, C, and F. T here was what? A, G, and H. It had to be a GH no matter what. This is W, T, and R. This is XRS. This is FIG. W here. Okay, so what was this? This was D here is W, Z, and U. D here is V, Z, and W. W here was D, G, and F. W here is E, G, and D. H here. So I think it was this part that was interesting. Right. So we knew AGH and BCI had to be 9 less than C and G. the sum of C and G, which is RTW and UXZ. That means if you add those together, and they're all different numbers because they're all different letters here, and they have to be different letters in, they cannot be the same digit in each set. That means at minimum, this is 21, and at maximum, these add up to 39, which is exactly 18. Which means we know for A, B, C, G, H, I, you have 7, 8, and 9. Or sorry, you have 1, 2, 3, 4, 5, 6. That means 7, 8, and 9 have to be in D, E, and F. And the problem with that is this has to be at least D and F added together if it's here, which means, yeah, you have D, F added together, which is at least 15, plus G, which could be at minimum 1. So that would be 16 at least here. 16 to 24. Well, it can't be 24 because it can't be... It could be up to 8, 9, and 6. So that would be 23. So this is 16 to 23. Well, 9 away from that, you can't go up. You have to go down, which would mean this is 7 or less. Oh, actually... It could be 23. But then this would have to... Okay, so then... I need to figure this out. If this is V, because if this is W here, that means D has to be here, and this can't be blue. It has to be the red, which is V. So V was here. It would see D. That's the reason. It would see D, E, and... the blue. So it would be H. And the problem is D and E are guaranteed to be at least 7 and 9 or 7 and 8, which is, again, 15 at least. So there's never going to be a difference of 9 between these two. So we found out from that this cannot be the... this cannot be the blue, this can't be the red, because... Well, we found out this can't be red, which would force that to be red also. So this can't be red, which means this has to be blue. So we can delete all these. So if this is blue, this has to be red here, which means this can't be red. That's blue, which makes that red. Blue eliminates blue here. Red eliminates red here. Red eliminates red here. So this can't be blue anymore, so that's blue. This is blue, which forces this to be blue. This can't be red because of the red here. So that's what we had. I don't know why I deleted that. Okay. So then so we were basically trying to figure this out. This has to be at, and we tried this as less than 8. Okay, so what is this? What are these? V is B plus E plus F. E is V and W and S. S is E, I, and H. H is equal to T, Y, and S. So this has to... Okay, so we tried this as 8. And... I think we proved that it can't be 8 or 9. Right, because this... Okay, so... This is definitely... adds up to 8 at most, right? Because this is less than a digit, which is 9 is the max. So it has to be at least 8, which means one of ST or Y is 1. And because of that, this can't be 1. This can't be 1 either. Why did we know that? We knew that T couldn't be 1. How did we know that T couldn't be 1? Oh, because You have UXZ. Wait. Yeah, you have UXZ and HTW adding up to 39, which means it has to be 4, 5, 6, 7, 8, 9. So T could not be 1. S or Y is 1, so this could not be 1. So we tried to have this as... I found an elegant way of showing why this had to be a 9. I'm trying to remember. Or not elegant, but it was pretty... it made a lot of sense. We know S and V are 1, 2, and 3. That means W. So S and V are at most 2 and 3. This is next to 2 unique digits. And it has to be 9 away from both of them. So that means this is 2 at minimum, so that would have to be 11. So W had to be 6 through 9. I don't remember the clear way. We just went through all the different scenarios and we found that this doesn't work. Okay. Well, if we tried this being 8. Well, we know S, T, and Y do not add up since T has to be at least 4. This is adding up to at least 7, right? So that means this is either 8 or 9. And we tried to have 8 here. So we tried 8 here. This is 7, so that's 1, 2, and... Oh, that was it. This is 1, 2, and 4, if that's the case, right? Well, this is 4, then. This is a 1, 2 pair. That means this can't be 1 or 2. It has to be 3 at least, which makes this 12. So we had 3, 12 at least. This has to be 9 greater than that, so it's 21. So this would have to be 4. I think we tried this as 9 was the key. This was 1, 2 as a pair. This was 3. This was 4. So why didn't that work? This would be 4 plus 8 plus 9. Why didn't that work? So again, you had... Oh, the reason is because this would have to be... So this would be 3 at least, if this is 1, 2, 4. We tried 8 here. So this is 7, 1, 2, 4. Oops. This is 3. We have this being 12. This is at least 21. This is 4, though. So this must be 4, 8, and 9. Obviously, this can't be 8. So this is 9. This would have to be 7, then. Oh, and the reason... Okay, so then how would this add up to 12? You have 7, and then that would be at minimum 5, because it sees 1 and 2. So it'd have to be 7, 5, and 1, which adds up to 13, which doesn't work. So that's the reason why that couldn't be 8. So this had to be 9. This is adding up to... This is either adding up to... This has to add up to 8, no matter what, because we tried 1, 2, and... So if we try 1, 2, 4 again... Okay, so the same problem. If you have 1, 2, 4 here, this would be 3, this would be 9 away from 3, that's 12. This is 9, at least 9 away from 12, that's 21. And then this would be 4. So this would have to be 8 and 9. So this would be 8. This would be 7 again. And you'd have this at minimum as 5. Because you see 3, you see 1, 2, and 4 in that cell here. So that cannot be... that would have to be 5 plus 7 plus at least 1, which is 13. So that doesn't work if this is 7. So this has to add up to 8. So again, T was 4 or 5. I think... The problem was we tried to make this 1, 3, and 4 in T, S, and Y. So this can't be 1, 3, 4. That means this could be 2. And this could be 9 away from 2. That would be 11. This is at maximum 22. Because this is at least at most 5. So 5, 8, and 9. So this is at most 22. Which means this is at most 13. Which means this is at most 4. So if this is 1, 3, 4, this would be 2, guaranteed. But the problem is, this would be 4 again. 9 away from 2 is 11. So this would have to be at minimum 5. So again, you'd have 5, 7 at minimum, and 1 at minimum here. That adds up to 13. 13 and 22. 13 and 9 away from 22. So this has to be at least 22, but 4, 8, and 9 is the max you can have and doesn't add up to 22. That's the reason we found out this was not 2. So we found out this has to be 3 or 4. This must be 1, 2, and 5. So this is 5 here. We know this is 1 or 2. And then we tried to go through different scenarios, right? Like this, trying this as 9. I don't remember why we had that. Okay, so this was 5. We tried 21 here. Either way, you're guaranteed... Oh, that's the reason why. You're guaranteed one of these has to be a 9, right? It's either 5, 7, 9 or 5, 8, 9. Because this is 3. 9 away from 3 is 12. 9 away from 12 is at least 21. So this is 21 or 22, which means it's either 7, 9 or 8, 9. And 9 can't be here. So this is guaranteed to be 9 here. What else did we find out? This can't be 9. This can't be 9, so 9 has to be here. I think we tried 7 here. So it's a 5, 7, 9 here. Well, we know 9 has to be one of these two. How did I prove 5, 7, 9 doesn't work? So this is 21. That would make this 8. And this 7. This is 1, 2 as a pair. I think it was if I tried this as 7. No, that's not right. So 5, 7, 9. This would be 7 then, if that's the case. Which means this can't be 7. This would be 8. So then this would be 7 here. This is 3. Okay, so we know that's 3. Because we have a 1, 2 pair here. Now, I think I tried this as 4. Right? Maybe? Yeah, I tried this as 4. If this is 4, this becomes... at least 13, which means this is at least 22. So then this must be 8. And then this must be 7. But then this, again, has to add up to 13. This cannot be 1, 2, or 4. I guess it can't be to add up to 13. You can't have 1, 2, 4, 5 here. Because this is 1 or 2, this is 1 or 2, this is 4, that's 5. That would force this to be 3, because you can't have 7, 6, and another digit. So, but if you have 7 and 3, to add up to 13, it's 7, 3, and 3. And that's the reason why 4 doesn't work. So we know this is guaranteed to be 3. What about, so how did we know this was not 21 is the question, right? So let's just try it. 7, 8, 7. So this is 21. That means this would be what? This can't be 1. Okay, this 21, this would be 12. And the problem, okay, so that's the reasoning. We know this is guaranteed to be 3. This cannot be 1, 2, or 5. 7 and 6. So this is at most, okay, the reasoning why this can't be 21. This is either 12 or 13 because this is at most 22. So that means this is at most 13, but this is 3, so this is at least 12. So it's 12 or 13. That means if we try to have a 6 here, this is at minimum 7, remember, because it's 7 or 8. 7 plus 6 plus another digit does not equal, sorry, is greater than 13, which this is the most that can be. So this cannot be 6, therefore this has to be a 4. So if we try to have this add up to 21, it would have to have 7 here, which would force 8 here. And 8, 4 plus another digit is not 12. And that's the reason why we have a contradiction. So this must be 5, 8, and 9, and this is 22. Therefore, this must be 39 minus 22, because it's 3 other digits, and these have to add up to 39. And that means it's 17. 9 away from 17 is 8. So this must be 8. And we found out it cannot be. So B, C, and I are all add up to 8 here, right? This already sees a 4. So B, C, and I cannot be 4, therefore they must be 1, 2, and 5. Yes. So this adds up to 8. So these are 1, 2, and 5 here. And this digit this is 7 or this digit sees both F and E and the 9. So this cannot be 7, 8, or 9. It's at most 6. Since this is at most 6, this is at most 5 here. Right? But this concludes S and V. That's at most. So S and V is at most 2 and 3. 2, 3, and 8 add up to 13. 13 is 9 away from 4. So this can't be 4. This is 1 or 2. And it's the Y, it's the S 1 or 2 because the Y 1 or 2 is here. So this is S. So S is here, S is here. Where is S here? S could be B, but if we try to make it B, we know this sees A, it sees 4, and this would be 2 at most. We know 7, 8, and 9 are here. This is 6 at most here. So this would be 2, 4, and 6 at most here. That's 12. But this can't be 1, 2, or 3. So it would have to be at least 4 here. And 4 is not 9 away from 12. And anything higher, obviously, becomes less higher. So therefore, this can't be S. One of these two is, this can't be S. So where's the S in one of these 3 cells? It has to be one of these 3. Because again, this one sees the 4. So this can't be 1, 3, and 4 adding up to 8. This must be 1, 2, 5. So therefore, S cannot be here. We've shown S can't be here. So S has to be here. And since this is 1 or 2, and S can't be here, this is why Y can't be here, so this must be the 5. So this is 5 in that case. This has to be 7. So this is 7, this becomes 8. This is 1 and 2. This has to be 3 and 6. Okay, so let's... So... Whoops. Let's purpose these. Okay. This is 3 or 6. This is 3 or 6. This is 1 and 2 as I. We had I there. We changed it to I, and this is C. So this is I, C, and this is not S. This is C. So we have 1 and 2 here, 1 and 2 here, 1 and 2 here. So where's C in column 6 then? Can't be here because C's in the box. Can't be here because it sees this C, and this is 5. So we have C here also. So this is 1 or 2. And this has to be, so this has to add, this is 8. This must add up to 17 at least. We see 3 and 9. That's 12. So it must be 5 or 6 here. And we can't have 5 because we already have 5 in the red cells. So this is 6. So then this becomes a 4-7 pair here. This is 3 and 6. This is A. Oops. We have A and G. And this was Z and X. Okay. So this is 1 or 2. We try... Okay, so this can't be 1 or 2 here. This is the sum at least, at most, of 7, 5, and 2. That's 14. 14 minus 9 is 5. So this would be 1 through 5. This is 3, 4, 5. This is 1 through 5 here. We have 1, 2, 3, 4, 4 in column 5, which eliminates 1, 2, 3, 4 in the rest of the column. So we have 5 through 9 here. 5 through 9 here, and 5 through 9 here. This can't be 9. No 7, 8, or 9 here. No 7, 8, or 9 here. This becomes a 5, 6 pair, which eliminates 5 and 6 in the rest of the column and the rest of the box. This can't be 5 or 6. It's 2 or 4 to be greater than 1 or 2. This has to be 1, 2, or 3. Did I miss... Oh... This sees, so these cells see both this 3, 6 and that 3, 6, and they must be different digits. So this cannot be 3. This is 1 or 2 here. This is 1, 2, 4, 5. This can't be 1 or 2. Cannot be 3 or 6. It's 4, 5, 7, 8, 9. Cannot be 8 because of 8 in the column. This has to be 1, 2, 4, or 8. This is 1, 2, 4, or 8. But... This is 7. Sorry, not 7. Doesn't matter. 2, 3, and 8 add up to 13, which is 9 away from 4. So this is 1 through 4 here. This cannot be 1 because one of these 3 is 1 here. So it's 2, 3, or 4 here. I cannot be here. Okay, so where's 9? 9 in box 8 cannot be here, it must be here. Where is 5 in box 8? 5 can't be here because of 5, 6 pair, can't be here, so this must be 5. And that's how we show. So where's I in column 4? It cannot be here, so it must be one of these two. Which means I cannot be here, C is here, so this cannot be 1 or 2. It's 4 or 8 here. Okay. That means we know 9 is one of these two. This is the sum of at least 6, at most, sorry, 6, 2, and 9. 6, 2, and 9 add up to 17, which is 9 away from 8 at most. So this has to be 1, 2, 3, 4, 6, 7, or 8. So 9 has to be one of these two. 5 cannot be here because of 5 in the column can't be here. So 5 has to be one of these three. And I think we tried to have this being 5, and we found that that doesn't work. Is that right? So we tried 5 here. Is it, we tried 5? I think so. We tried 5 here. Oh, interesting. I didn't notice that. But C and I both see this cell. So 1 and 2. So where's I in... Where is I in box 3? I can't be here. I can't be here. I is one of these three. That's not helpful. Okay, so this is 8. This is 17. So it sees 6, 4, and 7, which adds up to 17. I think we tried that as 5. Well, we tried basically this being this being 2, I believe. Right, so we tried that as 2. This is 4. This becomes 2. This is 1. That's 2. This then is a sum of 5, 1, and 7 at most. Oh, okay. No, we didn't try that first. What digit is here? If this was 4, that means this adds up to at most 5, 4, and 2, which is 11. Which can be the case if you have 1 and 2 here, but you can't have 1 or 2 here. So this cannot be 4. This is guaranteed to be 7. This is guaranteed to be 4. So 7 cannot be here. We did try this as 2, this is 2, this is 1. What did that mean? That means 5 cannot be either of these because this adds up to 1, 5, and 7, which is 13, which is 9 away from 4 or less. So this can't be 5, which forced this to be 5. This is 2. 2. This is 4, 5, and 3 at least, which satisfies that. But we ran into a problem. I don't remember what the problem was, though. This is 2. This is 4. This is 8. This is 1. This can't be 2 here. This can't be 2 here. Oh, this was 2 again. So this is, again... Wait. I think that's the correct one. I think we tried 1, 1, and 2? No, 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 that's definitely not correct. This is definitely not the correct way. Okay, this was 9. Oh, it was this part, I think. This was 9, which forced us to be 8, which forced us to be 7. So this was 9. This is 20, so that's fine. 9. This... So 8 had to be one of these two. 8 couldn't be here. What was the contradiction? I'm trying to remember. This became 3, 6, or 8. Ah, and this was 4. Which means this can't be 4 here. That would be 1, so this would be 2. This couldn't be 1, 2, or 4, obviously. This was 4. Because there's no other place for 4. Ah, we have a contradiction of 8 and 8 having to be here. That's the contradiction. Okay, so then we found out this C could not be 2. C had to be 1. So C was 1, which made this 1, which made that 2, this 1, 1, and I was 2. Okay. So 1 couldn't be here. This could be 14 still. Oh, so this is a contradiction when this is 9, period. So if this is 9, this is 8. I think. This can't be 1. Remaining digits in box 8 are 2, 6, 7, 8. 2 can't be here. This cell can be 2, 4, 6, 7, 8, but 6 is guaranteed here. So this can't be 6. 2 is one of these. 2 can't be here because of 2 in the box. So no 2 or 6. This is 4, 7, or 8. This 7 eliminates 7 here. So this just becomes a 4, 8 pair. Right. And this is the contradiction, I believe. If this is 9... Okay, so... If this is 9, this becomes 8. Well, maybe that's not a contradiction. Anyways, this is a 4, 8 pair, which eliminates 8 here. So this becomes 2, 6, 7. 2, 6, 7 eliminates 2, 6, 7 in the rest of the box. This is 8, which makes this 9. Okay, that's the reasoning why. This is 9. This can't be 9 here. This 9 eliminates 9 here. Where's the 9 in box 1? It has to be here. So this is 9, which eliminates 9 here. So this is 9. And we know 5 then has to be one of these two. Which makes... Well, we already knew this was... Okay, well... Yeah, 2, 5, and 7. Or 2... Yeah, 2, 5, and 7 add up to 14. Which is 9 away from 5. So it was really this part here that was basically making that 8. So this can't be 8. This is 7. Obviously, this can't be 4 or 7 here. Okay. Remaining digits in column 4 are 3, 6, and 4 or 8. Okay. This sum is up to 14. Or it is 14. 14 is 9 or more away from 5 or less. So this can't be 2 or 5. It's 1, 3, or 4. 1 can't be here because of 1 in the column. 4 can't be here because of 4 in the column. This sum is 13. Is that right? Yes, 3, 6, and 4 add up to 13. 13, and this is 7, 8, and 6, which is 21. 9 away from 13 is 1 through 4. So this is 1 through 4. And we found out where's 5 in row 5. Cannot be here. None of these can be because this has to be 9 away from 13, which is 8, 3, 12. This can't even be 4. Right. So this is 12. 9 away from 12 is 2 or 3, so this can't be 5. 5 can't be this because of 5, 6 pair in the box, so 5 has to be one of these two. Well, where's 5 in row 6? 5 can't be here. 5 can't be here, so this must be 5 here. So this is 5, which makes that 6. Remaining digits in row 8. 1, 2, 3. Oops. 1, 2, 3, 4, 6, and 7. And this cannot be 3 or 6 because they see both A and G. So no 3 and 6 there. 8 cannot be here in box 7, so 8's one of these two. So 8 can't be here. 8 has to be one of these two. Um, 1, 6, and 9 add up to 17, so 8 could be there, right? Huh. Remaining digits in row... Let's do... Okay, so where is 6 in row 6? Can't be here because 6 in the box. Can't be here because it must be 9 away from 13. So this must be 6 here. Oh, and this 6 eliminates 6 here, so this is 3. So this can't be 3 anymore, it's 6, which eliminates 6 here and here. This is 3, which eliminates 3 here, and eliminates 3 here, and 3 here. This sum, then, is 1, 3, and 9, which is 13, which has to be... So it's 13, which is 9 away from 4 or less. So this has to be 4, because it cannot be 5. So this is 4, which forces this to be 5, and this has to be a 1-2 pair. So this can't be 8 anymore. This is 8, which forces this to be 6. That 8 eliminates 8 here, so it's 4 and 8, which means this can't be 8. No 4 here, no 8 here. This is no 6. Whereas 9 in row 3, it has to be here. So that eliminates 9 here, and 9 has to be there. That gives us all the 9s. This has to be 3 or 8. It cannot be 8 because of 8 in the... it can't be 1 or 2 because of the 1-2 pair in the box, or in the row. So this can't be 8. This is 3, which makes this 8, which makes this 6, which makes that 3. Remaining digits in row 1. Oh, again, this is a sum of 2, 6, and 8. That's 16, which is 9. 16 minus 9 is 7 at most. So 8 cannot be here. 8 cannot be here in box 9, so 8 has to be one of these two in column 7, which eliminates 8 here. So this becomes 5, 7, and 5, 7 as a pair. This can't be 2. So it has to be 6 here. This is 2. Really? Huh. This is 8. I thought, for some reason, I kept thinking this was 2. Huh. Maybe that's a contradiction. Interesting. Okay. Anyways, that's helpful, I guess. So 2 cannot be here. 2 is one of these 2. This is 1, 2, 3, 4. But this can't be 2 or 4. We have a 1, 3 pair in column. And this, we have a 1, 3 pair in column 8. This can't be 5 because of 5 in the row. And this can't be 1 or 3. So this is 7, which makes this 5. I think this was the problem here. We have a 2 there. That's different. This can't be 2 or 3. This can't be 1. This can't be 4. So remaining digits, this 4 has to be one of these two. Remaining digits in box 6 are 1, 2, 3, 4, and 7, but can't be 4. So it's 2, 3, and 7 here. This can't be 2, 3. So this is 1 or 7 here, and this 1 eliminates 1 here. So therefore this is 7, which means this can't be 7 here. This can't be 3 because of the 3 in the row. 4 is one of these two because 4 can't be here. So this must be 2 here, which makes this 4, which makes that 2. This is 3, that makes that 4. This 3 eliminates 3 here. And the 2 here means this can't be 2. This is 1, 3, 4. It's a triplet, so this must be 2 here. That eliminates 2 here. Again, this can't be 2. We have a 3, 4 pair in columns. This 7 eliminates 7 here, so this is 5, and that's 7. That leaves the remaining digits in column 7 as 5 and 8. 5 can't be here because of 5 in the row, so this is 8, this is 5. 7 eliminates 7 here. Okay, this can't be 4 anymore. Remaining digits in row 4 are 1, 5, and 7. So this is 1 or 7. No, not 1 or 7. This is 1 or 5. This becomes 1 or 7, and this is 1 or 7 here. So this must be a 5 here. This can't be 4 or 7 here. So there must be a 1, 3 pair here in row 8, which eliminates 1 and 3 in the rest of the row. So this can't be 1 or 3. This is 4, this is 3, which makes this 1, which makes that 4. 1 eliminates 1 here, so it's 3, which makes this 1. Yeah, I don't know how, like, that 2 is the different one. Is the different part. So I guess, I don't know, I must have had some really weird thing there. Anyways, this can't be 1. Remaining digits in column 1 are 3 and 8. This can't be 8 because of 8 in the row, so this is 3, this is 8. We have to have a 4 in column 3. Can't be here, so this must be 4 here. That leaves a 6, 7 pair in row 9. This can't be 7 because of 7 in the box, so this is 6, which makes this 7, which makes that 2, which makes that 6. 2 eliminates 2 here, so it's 7, which makes this 1, which makes that 2, which makes that 1, which makes that 7. That leaves this as a 2 and this as a 1. Oh boy. Okay. That was, yeah. Pretty crazy. That was definitely... Dude, that took 51 minutes just when I had all the logic there. Again, I was explaining everything but I was trying to also make sure the logic was sound throughout. So, I don't know. I just must have put a different value somewhere. Because I know I didn't have this as 2. I had 2 having to be one of these two. So, I don't know how I got that. Anyways, I hope you enjoyed these 3 videos about the solve. This was definitely very tough. Very hard. It fit the very hard moniker. Partly because, like, just the logic behind it was not... You had to basically come up with... You had to figure out what these sums had to be, right? That was a large part of it. But it was also trying to figure out it was not easy to figure out where the three-headed beast could be. It was not easy to figure out that these had to be essentially these had to be the certain sets of 1 through 6 and set 4 through 9. And then you had to execute well on basically figuring where things could be. So definitely very hard. Pretty satisfying, though, solving it, because there's a lot of very cool logic in there. And it was just, overall, just very, very well constructed. Anyways, I hope you enjoyed all 3 of these videos, and I'll see you next time on Frank Puzzles. Take care.